Great paper.
Good day, everyone. We're coming on here with breaking news. It has to do with golf superstar Tiger Woods, who has been injured in a serious car accident in Colorado, California. Just outside.
They believe there are still bodies inside some of that wreckage. Shep.
Nowadays, safety issues during driving become a great concern as a large number of fatal crashes happen every day, threatening the life and properties of human beings.
Hi, I am Siti Fatima Azara and I am a student Bachelor Science Honours Physics at UiTM Jengke, Pahang. I think most of you want to know what actually I want to discuss about. Yeah, I want to discuss about seatbelt. As we know, a seatbelt is the one of the component that very important in the car because it contributes to safety. So what actually happens if we are not wearing a seatbelt? If the accident happens, is that we can save or not? So actually I have got some video and let's rewatch it. Before we go further, I will show you the journal article that I refer to as my reference doing a research in material that used in seatbelt. This is the article journal that I refer as my reference, which the title is A Self-Powered Smart Safety Belt Enabled by Triboelectric Nano Generator for Driving Status Monitoring. Who writer is Zhuanjiao Feng, Jin Huang, Xiao Liu, Wei Qiu, Yang Li, and Hao Wu. This article journals were published on 2019. This is the APU tank schematic structure. The APU tank is composed of a cylindrical azotic PU foam and an outside shell. In order to fabricate the foam, PU foam was repeatedly gradually compressed in aluminum mold, heated and cooled down. The cell ribs of the PU foam were compressed simultaneously in 3 dimensions to buckle and produce a reentrant structure, which resulted in the azotic property. The stretching along one direction leads to expansion along orthogonal direction. The exotic PU form was made into cylindrical shape to render the expansion of the exotic PU form in all directions in uniform contact with the external friction layers. The inner side of the APU tank shell were made of two spirited triboelectric layers and their corresponding copper electrodes, which were covered by a polyimide Pi structural layer. In order to screen the outside electrostatic interference and enhance the stability, the APU tank sensor, a grounded shielding layer made of copper thin film, which is 50 mm, was attached to the Pi structure layer. A polyethylene triplet PET thin film layer covering the copper shielding layer acts as the encapsulation of the overall device. This is a CEM image of the PTFE surface with each nanostructure. And this is microscopic image of the craft paper surface. The craft paper was chosen as the triboelectric counter materials to the exotic PU form due to their tendency to generate negative and positive charge when contacting PU form, respectively, as indicated by the triboelectric series. This is the schematic structure of the AS tank. The AS tank consists of two arch-shaped components electrically separated by a polyimide layer in the middle. Each of them is a tank unit, as shown in the figure. The triboelectric layers in the top arch are microstructure PTFE thin film and aluminium thin film, while a polyimide layer and another Al thin film function as the triboelectric layers in the bottom arch. Copper films acting as the electrode for the AS tank were attached to the PTFE layer and PA layer respectively. Similar as the APU tank, two grounded copper shielding layers which were separated from inner parts of the AS tank by structural PI layers were also integrated into the device structure to screen outside electrostatic interference. The overall device was encapsulated by a PET film. As we can see, PA and PTFE are located in the far ends of the triboelectric series, while AL is in the middle. Therefore, when contact occurs between the AL and PA tribo pair, negative charge tend to be generated in AL and positive charge on PA, while negative charge tend to be generated in PTFE and positive charge on AL for the AL/PTFE tribo pair. By connecting the two copper electrodes on the back of PTFE and PA with opposite electric potential to external circuit, the two single electrode mode tanks in the top and bottom arch form a mixed mode tank. 2x3 arrays of T-mix were fabricated and attached, which we can see at the safety belt for monitoring of the driver's turning. Now let's move on to the work principle of APU tank and AS tank. When the external strain along the axial direction is reduced and the PU form is separated from those two friction layers, the copper electrode on the back of PTFE layers will have lower electric potential, while the back electrode for the craft paper layer will have higher electric potential. The electrostatic induction due to the different electric potential of those two copper electrodes drive the electrons to flow from the top electrode toward the bottom electrode. This process continues until the PU form is completely released and electrical equilibrium achieved and the charge transfer stops. When the PU form is stretched again, electrons will flow in reverse direction. The APU tank generates alternating electric signal through the periodic contact separation of the tribo layers. For the AS tank, we can see that when the pressure is retracted, the copper electrode on the back of PTFE layer will have lower potential than the electrode on the back of the PA layer, which drive electrons to flow from top arch to the bottom until the pressure is fully retracted and an electric equilibrium is achieved and the electrons stop moving. Once the pressure is applied again and the ribbed tribo layers come closer to each other, electrons flow in the opposite direction, and after that, the cyclic generation of potential difference between the top of and bottom electrodes was numerically studied in the COMSOL multi-physics software. Okay, based on the article journal, I can summarize that self-powered smart safety seatback, which is based on tanks, have been fabricated, and its application in driving status monitoring have been demonstrated. And the APU tank and AS tank sensor error integrated on the safety belt enable the monitoring of aggressive declaration and turning action of the driver. Okay, and the unique negative representation of the PU form enable the APU tanks to demonstrate high sensitivity of 0.89 V equals to /cm squared for strain measurement for large strain in a range 40% until 100%, providing the capability of measuring forward position of the driver in large range, and thus the monitoring of abrupt and declaration. Meanwhile, the structure of the AS tanks were designed such that the contact and separation of the triboelectric layers occur gradually and stably, and the optimized structure led to high displacement, measurement sensitivity with high linearity, and the open circuit voltage output from the two sensor array of the AS tanks and their relative magnitude can be effective indicator of the turning direction and angles of driver. Last but not least, this work provide an effective strategy for the development of smart safety belt with self-powered tanks, which is TENGS, and may extend the application of tanks-based wearable sensor for driving status monitoring in vehicle, aircraft, and spacecraft. Actually, there's a lot of explanation that I want to explain about this smart seatbelt, but yeah, we have a specific duration time, and but this time I want to thank to my lecturer physics PHY 535 Miss Infaza. Thank you for letting me doing this assignment. You enjoy it, and thank you for watching. I hope you understand. Thanks for watching.